Okay, so next we will look into what if you put two wires that are carrying currents, right, next to one another. What will happen? Okay, so if you have two wires carrying current, right, that are in the same direction. So let's just say you have I1 here flowing upwards and I2 flowing upwards also. So they will experience attractive forces in this direction. Okay, and if you have current that is flowing in the opposite direction, I1 here, I2 downwards, they will feel a repulsive force. Okay, so you can think of it as light current attract, okay, and light current repel. Okay, or you can even deduce it using the concept of Fleming left-hand rule. Okay, so let's us take a look at the diagram A. Okay, so diagram A is this, right? Yeah. Okay, so okay, so now I look at the second wire. Okay, so second wire is this. Okay, so this second wire will of course have its own magnetic field. It will also experience a magnetic field due to the first wire. Okay, so let us determine what is the direction of the magnetic field caused by the first wire. Okay, so if you have look through the electromagnetism 1, so if we use a right hand grip rule, right, we look at the first wire. Okay, if you use your right hand grip rule, your thumb is upwards, okay, and you curl your four fingers. Your four fingers will be the direction of your magnetic field. Okay, so if you curl on the left hand side of your first wire, the magnetic field will be out of the paper. Okay, so out of the paper, maybe I just put all the dot here. Okay, and the right hand side of your first wire will be into the paper. Okay, so this will be into the paper. Okay, so the second wire is experiencing a magnetic field caused by the first wire that is pointing into the paper. Okay, so how do I determine the direction of the force on the second wire? You can use your Fleming left-hand rule. Okay, so Fleming left-hand rule, your FBI, right? Okay, so B is into the paper, your current is pointing upwards. Okay, so if you point correctly, right, your thumb will be pointing towards this direction. Okay, yeah, so your second wire is experiencing a force that is in the direction towards the left. Okay, so let's take a look at the first wire. Okay, so first wire also experiences a magnetic force, right, due to the second wire. Okay, so let me erase first. So for the second wire, okay, it will create a magnetic field on its own due to the moving current, right? Okay, so if you use your Fleming left-hand rule, we look at the second wire now. So you use your Fleming right-hand rule, your right-hand grip rule. Okay, so your thumb is pointing upwards in this particular direction, and you curl your four fingers. Okay, so you notice that on the left-hand side of your second wire, the magnetic field is out of the paper. Okay, so out of the paper, I just put that. Okay, so the first wire experiences the magnetic field out of the paper. Okay, so now we look at the first wire right now. So you use your Fleming left-hand rule, your magnetic field, your index finger is pointing out of the paper, your current is pointing upwards. Okay, and you will notice that your thumb, which is the direction of force, will be pointing towards the right hand side. Yeah, so that's why they will be the two wires will attract one another. Okay, yeah, so this is how you determine the direction of the force caused by two wires. Okay, so let us take a look at diagram B. Okay, so diagram B, the current is flowing in opposite direction. Okay, So okay, so same thing, first wire and second wire. Okay, so let us take a look at the second wire first. So it will experience a magnetic field due to first wire. Okay, so let us determine, looking at the first wire, what is the direction of the magnetic field. Okay, using your right hand grip rule, your thumb point upwards, okay, and your four fingers will curl around the so-called first wire. Okay, on the left hand side of the first wire, your thumb will be out of the paper. Okay, out of the paper. And on the right hand side of your first wire, you notice that your four fingers are curling into the paper. So this will be into the paper. Okay, so your second wire is experiencing a magnetic field that is flowing into the paper. Okay, and okay, so now is a good time to use our Fleming left hand rule. Right. So your current, okay, so we look at the second wire now. Okay, so second wire, your current is flowing downwards. Okay, so your middle finger is pointing downwards. Your magnetic field is pointing into the paper, so your index finger is pointing into the finger, and if you notice that now your thumb is pointing towards the right hand side. Yeah, so that's why your force, your magnetic force is pointing towards the right hand side. Yeah, okay, so now we determine the force on the first wire. Okay, so let me just erase this. Okay, so the first wire will experience a magnetic field due to the second wire. So second wire. Okay, so let us see what is the magnetic field due to the second wire. Okay, so second wire, the current is flowing downwards. So if you use your right hand grip rule, your thumb will be pointing downwards. Right, and you curl your four fingers. On the left hand side of the diagram, you will notice that the magnetic field is into the paper. Okay, into the paper. So the first wire will experience a magnetic field that is pointing into the paper. And the right hand side of your second wire will be out of the paper. Okay. Okay, so now we look at the first wire. The first wire is experiencing a magnetic field into the paper, and the current is pointing upwards, right, as seen in the diagram. Okay, so now we go to our Fleming left hand rule. Fleming left hand rule, your magnetic field into the paper, so your index finger is into the paper. Okay, magnetic field into paper, index finger into paper. Your current is pointing upwards. Okay, so you notice that your thumb is pointing towards the left. Okay, leftward direction. So basically your two wires will repel in this sense, right? Okay, so what about the magnetic field of the two wires, right? So if the wires are flowing in the same, if the current is flowing in the same direction, the magnetic field lines will have this particular pattern. Okay, and if your current is flowing in the opposite direction, your magnetic field will have this particular pattern. Okay, so just remember, like current attract, unlike current repel.